So let us start the works of the second part of the morning. I would like to kindly invite to the floor Christian Bassi and Massimiliano Fontanesi of the 𝐃𝐞𝐞𝐧 Group, Alessandra Bruni from 𝐷𝐼𝐀𝐍, and Andrea Galdino, SIC. These contributions have a presentation, a PowerPoint presentation. So many thanks. First of all, I would like to thank the participants, and I would like to thank 𝐷𝐼𝐀𝐍 for the possibility they've given us to present this experiment. This is no longer an experiment. We are already in the implementation stage. This is a collaboration between our group. I am representing 𝐆𝐈𝐀𝐻 Mantova. That's the distribution company of the utility, of the Mantova utility. In our company, we have a number of services that we offer: remote warming and renewable sources of energy. 𝐆𝐈 is the 21st largest Italian company, so as to give you an idea of how big we are. So it's a medium to small business. And looking at the numbers, you can already understand what it is. It is a provincial company. It manages about 900 kilometers network gas. We have about 70,000 customers. We are within 2 ATEM, so 2 district areas, basically. The main one is Mantua 1, and the second one is Mantua 2. And we are the leading company in the Mantua 1 area. And we are the second company in the second one. We manage 10 municipalities, including the city of Mantua, which is the main town in the 𝐃𝐞𝐽 Group. The 𝐃𝐞𝐽 Group is a group that basically is a multi-utility group, and it is very largely present in the area. In order to give you an idea of what we do, and we're going to listen after myself to Ms. Bruni and Dr. Bassi concerning the technical aspects. We also manage about 150 distribution groups and 4 REMI cabinets, so as to give you an idea. The main challenge we have is a very peculiar one. This is thanks to the collaboration with the 𝐷𝐼𝐀𝐍 Group, so with Mr. Giorgetti. Actually, we have been collaborating with 𝐷𝐼𝐀𝐍 for over 20 years to manage all the problems related to the distribution of the gas network. And over the years, we've carried out a number of installations. We have about 600 golem devices, so 600 application devices that manage cathodic protection and that partly manage the deodorizing system and that do the measurement of the network. So we've had the chance to collaborate with them, and we've reached a stage in 2017-2018 in which we wanted to experiment what we're going to present to you in short. We decided to start with an experimentation that is the Golem project that basically led to the experimentation, an experimentation for 2 years, and we've already achieved some nice results. The experimentation was carried out locally, so only a few installations, 3 reduction groups with this system. So we tested them, and then over the years, we decided to invest in this. Last year, the company board of directors gave us the possibility of establishing a partnership with 𝐷𝐼𝐀𝐍, so we implemented this project, which is a very ambitious one. It is an ambitious project because it gives us the chance to control and digitalize the networks. It gives us the chance to eliminate any dispersion, any leakage, and also to comply with the regulations of the European Union, to comply with the indications of our authorities, to have an efficient network, to be able to inspect it and therefore be safe. We are small, but like I said, we are very ambitious, and so we invested and we decided to implement in this very same project the division into districts of the gas networks. What do we mean by division into districts? This is a new development that we introduced in gas distribution for some time. In water, it's already present. So we established a partnership on a project authorized by the board of directors. And so in this respect, I would like to thank our managing director for this. And thanks to this partnership, we carried out this experiment on a pilot project in a small municipality. There too, we are currently we are about to start next week. So we will need to start with the division into districts in all of our territories. So over the next 4 to 5 years, we're going to carry out this division into districts. And here you see the advantages that you can have. So we have efficient leakages with the reduction of fugitive dispersions, fugitive leakages, the quantification of fugitive emissions, then digitalization of networks and big data. As regards ARERA, which is a regulatory institution, the measurement of interconnection points between different distributors inside our concessions, we have interconnections with other utilities, with other distributors. As regards SNAM, another advantage lies in possible scenarios of emission of hydrogen mixtures in the local distribution network, and as a whole we can have better security and safety and efficiency in the management of networks. So predictive maintenance and optimization of processes of leakage, of the search for leakages. This is basically what we've had. We've had the chance to collaborate with Automa. We started collaborating with Automa for over 20 years, and we have the chance to exchange views with the people from Automa, and so far results are very performing ones. So I really hope that during the installation stage we will continue with this. We've already installed 20 groups already. By the end of the year, we should be able to install 40 groups. The objective is to have some good results. For the time being, we have not yet seen any results, but we expect to have some information from the field to better manage the processes that I mentioned before. Now, I'd like to leave the floor to Engineer Bassi, who will talk about the technology and the IT features of the project. So, first of all, thank you very much. Last year, we talked about this initiative that was in its initial stages. We talked about an initiative that was at the beginning, but it was at the very beginning. I'm here representing the IT part of the gas distribution project. At the beginning of the call for tender, we had already indicated in the specifications a number of technology and safety requirements that had to be complied with during the initiative. At the moment, the TEA group is in the middle of a very virtuous pathway, which is that of dematerializing the data centers, so the IT systems. And we are currently adopting 2 cloud platforms, because our idea is to keep the management and the remote control fields separate in order to give redundancy to this, in order to make sure that what happens in a field does not have repercussions on the other. So remote control activity doubled these activities last year in the local cloud platform. The symbol is not seen here, but if you are familiar with the icons, of the cloud services, what you see are services which are Oracle Cloud services. And we chose Oracle Cloud because the SCADA, which is the system with which Automa talks to, it has its remote control system, and it has to relate with remote group, with the remote control of the group. So remote control, gas, then water distribution. So group control covers all of these fields. The technology that we are using for the Automa solutions are based in cloud. You probably recognize the icons at the center of the display. So virtual machines, database, shared folders, but also a series of new services. Even if the word new should not be used by people in my field, because, I mean, in the IT sector, what's termed as new might be already belonging to the past in 6 months. So we have data sciences services, which is services used by Automa to build and train mathematical models, the models that then regulate the devices on the field. In the bottom part of the slide, you see the cross-cutting services. So, for example, entity management to make sure that the platform can be accessed only by people who are authorized and who have the authorizations. Then you have the data catalog to manage everything that is linked with metadata, the data catalog. These are concepts which in the field of data science is particularly important because they govern all the world related to data. Then on the right, the services that will be used, so data gate, data capture to immediately use the data that travel in the system, and then the various reporting tools that are in Analytics Cloud. I'd like to talk about security. At the beginning of our meeting, Engineer Capra talked about the issue of safety and security, data security. So utilities, especially in distribution companies, by the 18th of October, are called upon to comply with the new pieces of legislation, the MIS 2 pieces of legislation, and the fact that we opted for a cloud technology ever since the beginning places us in an advantageous position. Many characteristics that we're going to face will be facilitated by the cloud platforms when it comes to the X2. That brings with itself a whole series of technologies and ways of using data that basically go in this direction. So this solution already starts with a good imprinting, so to say. We are in the cloud world, so we followed all the Oracle practices as we're doing in the other cloud platforms. So we are already dealing with a very solid, resilient architecture and a safe one and a secure one. So, and I think that this is an issue that many of you will deal with the X2 aspects. So I wanted to bring this aspect to your attention, which relates very much to safety. Thank you very much.
Okay, buongiorno.
So good morning, my name is Alessandra Bruni. I am in charge of the customer care service and project management for Automa. And I'm here as representative of Automa for the Giant project. I'd like to mention this because this is a project that saw the participation of many people, starting from the people of the project management group, the research and development group. So the big difficulty now will be to describe this project in just 10 minutes because there's many actors involved. GIANT is the acronym for Gas Integrated and Automated Network Technology. The GIANT project implements and provides a solution on each of the 4 levels that you see in the slide, which are the very basis of automation. So it gives a solution in the field of field devices, so for example, actuators, sensors, our smart regulator Golem. It implements solutions for the control level. So for those who are experts in the field, I'm talking about PLC. Our devices are similar to PLC devices like the G5P, G4G Pro. These devices serve as they collect all the data that come from the field, so from the actuators and the sensors, and they collect all the data locally and then send them to an upper level, which is a supervision level. The SCADA system, for those who know us, and our web ProCAD and web pressure systems. All this data, and that's the additional step we made, all this data is then given to yet another, a higher level, and that implements the decision-making system. So the acquisition of this system has made it possible to, in a way, make automatic decisions in the three sectors that we're talking about. So the monitoring of cathodic protection, the injection of authorizing agents in the gas distribution networks, and then the dynamic regulation of networks. So Automa has provided solutions for each of these four levels. So the Giant project basically touches upon each of these levels, these four levels. This is basically what I was talking about before. We have a centralized system that collects all the data and that implements 5 artificial intelligence engines. We will then have a look at them more in detail, and if you would like to have even more detail, we will be later on at your disposal to answer any other questions or curiosity you may have. This is stated it comes from the web ProCAD and web pressure systems, which in turn receive the data from the field devices that collect all the data, again collected from the sensors. We do not only talk about sensors, but also actuators. So dynamic regulation of actuators, which are our Golem devices. They make it possible to change the set point of exit pressure in the various reduction groups, or a hub in the various cathodic protection systems that enables us to define smart set points for the power that is given by the various supply units, power supply units. Giant is a project that started this year. In the past, we may have described it a bit, but it was really tangibly implemented this year. It will be implemented over 4 years. In the first year of implementation, we are completing the installation of the sensors that are necessary to acquire data and then give this data to the various artificial intelligence engines. So we basically started with the installation of our Golem 0 device. It is a smart regulator. And just to give you any figure, as Massimiliano said before, in Mantua there are about 143 𝐺RF cabinet units. And this year we foresaw the installation of the Golem for a total of 110 Golem systems. Another important aspect it enabled us to work with TEA was that we have a very large regulator park, so we actually had to deal with a number of piloted and selected regulators, which means that we already have a Golem solution that can be applied and that can be reproduced for the large variety of regulators currently available in this field, and which are used in the whole of Italy, in Europe, and even in Latin America, as we've recently seen. So these are more or less the figures related to Golem 0. We did not only have to install the Golem device, but the collaboration with Mantua is a 20-year-long collaboration. Mantua already had some devices that served as regulators like the RTU for the collection of data. But what we did was a technological upgrade of these devices especially for communication purposes. And we also carried out an energy upgrade because all the cabinets in Mantua and in the area already had a photovoltaic installation, but we preferred to have an energy upgrade, and all cabins were equipped with solar panels of 430 watts with the bifacial technology. Smaller in size, given the power of the solar panels, because we are talking about 1.1 by 1.07 meters. Also, technology was upgraded. We are now using the latest technology for the batteries in this context, which are the lithium iron and phosphate batteries with a very important capacity, 173 ampere per hour. Another sector in which we operate are the various the measurement of odorizing agents in the line. In Mantua, there were already spectra items. What we did was the implementation of optimizing the energy consumptions of this device and also improve the spectrographic techniques. These are pictures really taken in Mantua. This year, we are serving 71 cabins for a total of 110 golems. You can see that there is a complete unit. That's an area in which you have the 5P, the double line, the spectra system in the box in steel that you see in the bottom left-hand part of the picture. These are two examples of complete cabinets, and that is because we have a higher consumption, so we had to take that into account. Now, cathodic protection. In Mantua, all devices were could be controlled remotely, and now we improved the telecommunication technology. So we equipped all installations with latest last generation modems. And for those who know us, the solution that we normally use is the battery ones, but in this case we wanted to use the box solar. One case is open there, but on the other side you see that there is a solar panel enabling these devices to work in high power mode and always to be accessible. And that is because we start from the devices and then have a system in which we can make decisions. And decisions are made based on measurements that come from the field. So any variation in pressure or in cathodic protection values has forced us to have devices that could be always accessed. And in case of an anomaly, to send a warning, and this could not be possible if we used a battery system. So what we are doing now is to install the practical part to then acquire the data, and the data will then be sent to artificial intelligence engine, and there are several goals, having dynamic regulation, predictive maintenance, or, for example, in order to reduce costs and achieve better energy efficiency. And when it comes to artificial intelligence, let me briefly spend a couple of words on this. We are currently implementing 5 artificial intelligence engines. 3 involve dynamic regulation. the dynamic regulation mechanisms of pressures based on measurements of the bottom of the network, which are powered by solar panels. Also, the bottom of the networks are all equipped with an external supply unit, power supply units. Then, dynamic regulation of the injection of the odorizing agent based on the measurements of odorizing agents in the line. Then the dynamic regulation of the current of cathodic protection given by the various power supply units based on the measurements of a critical point that is powered externally of the cathodic protection system. And then there are two algorithms, two applications of artificial intelligence that concern predictive maintenance. And in this case, we're talking about cathodic protection, in the sector of cathodic protection, for the evaluation of the state, the efficiency state of the dispersion and of the electrode. 5 minutes to close it. So you have 5 minutes left, including the speech given to Andrea. So the automatic regulation of the networks, we're currently collecting this data. The data will be given to our neural networks to train the model. And the aim is to make sure that once the neural networks are trained and once you have an entry data set, we will achieve an expected output. The training uses this data in particular, so the historical data of the pressures acquired from the field on the GRF, the adjustment network, the type of network, or the end of the network that is on a specific ring, the distribution map, historical data of the flows, and then even the data on environmental parameters, because they also impact on the consumptions, on expected consumptions, and the set point. So there will be an hourly set point of the target pressure, with the aim of guaranteeing the minimum pressure and yet sufficient pressure, operating pressure on the bottom of the network. These three algorithms all work at the same time. So there are points at the bottom, upstream and downstream, and so based on this data, we're training the neural networks. As regards the predictive algorithms, same concept. We will provide entry data to achieve some signalings that can be viewed and that concern the efficiency or inefficiency of the disperser. So there will be a signaling that, for example, a given disperser will come to an end of its life cycle over the next 3 years or over 1 year, for example. And I'm done with this. Thank you. Good morning. Good morning, everyone. I'll try and speak as fast as possible. Sika is a German producer of sensors for industrial automation. Thank you very much to TEA for giving us the chance to participate in this very interesting project. And we would like to thank Automa for their kind hospitality in this field. I would like to focus on the measurement unit, on the measurement element that actually carries out the measurements for the flow. The measurement principle, ultrasound measurer. For those of you who do not know it, that's its simplified version. Two sensors, A and B, they exchange data concerning the sound wave. When the flow is stopped, the time of crossing the wavelength are the sound waves are the same. But when the flow starts moving, there are some acceleration effects. Exactly as when we try and swim against the tide, so we're slowed down. So there are time differences between the passage between A and B and B and A. So these differences are very small, and yet they are detected by the electronic sensors, and so there is this delta T, which is proportional to the speed of the gas. Going more in detail on the values that are measured, you see this on the left is the shape of the measurement chamber that is characterized by two flow conditioning elements that the flow builds, shapes a U, and that is designed precisely to kind of adjust the volume and the profile of the fluid in a controlled manner. If we do that, you become independent from all the possible distortions of the profile that may be present upstream and downstream of the measurement point. In this way, the measurer is the only ultrasound volumetric measure that can be installed upstream and downstream. And this is very important to enter it, to use it in a 𝐺RF device. We've talked about data. When one talks about data, one has to say that this is an electronic measuring device. So there's a whole series of data that is detected to make the measurement, like the speed of the propagation of the ultrasound signal through gas. That's a very important parameter to develop a whole series of diagnostic routine tests. The first piece of data is gas speed, the gas speed bisection and the flow. And then also by detecting and measuring, for example, temperature, we provide the value in cubic meters. These volumes that we obtain, we can then have them in conditions referring to the good functioning or in a situation of error, of anomaly. Then there's a whole series of information that is detected automatically to define, to check if that measurement is good or not. These parameters are very specialistic and they have to be, in a way, used by skilled technicians. What we did was to carry out a much simpler advanced diagnostics. This provides the global status of the measurer, so good measurement or, for example, a warning situation that does not influence on the measurement but already provides you with a warning on the measurer and also nearby, up to a situation in which you have an error, and that error induces you to kind of register the measurements in another register. All these measurements become historical data, and later on you can have a troubleshooting exercise on these measurements and analyze the events, when they started, their duration, and this may be very useful to understand what really took place in the network. Then data flow. We have serial communication, so there's the possibility of bringing this data to an upper level of acquisition, of data acquisition. And as we have a 485 communication, which is bidirectional, we can give measurements and commands to the measure. So, for example, diagnostic tests or checks, input checks or output checks. We've talked about hydrogen. There are also additional features developed by our group, by SIC. Through the speed of propagation of the ultrasound, we developed an algorithm that makes it possible to define, if there's, for example, a blending of hydrogen and natural gas, the percentage of hydrogen which is present in the mixture, with a constant monitoring exercise. Also internationally, a whole series of studies and comparisons were carried out, for example, with gas chromatographers, and we've seen that there are very good responses with an accuracy of 0.1% compared to the readings of gas chromatographers, also carrying out dynamic tests. So to sum up very briefly, we have a device that has a measurement field that is very, very high. We are better results than rotoid measurers, and there's the possibility of measuring very low flows. We're talking about gas speed of 0.03 meters per second. So as soon as the fluid starts moving, that is immediately detected, and this is particularly important if one has to detect leaks. We can install it in 𝐺RF for limited tracks. We have diagnostic tests and its results sent to a higher level and low consumption. I was talking about the power supply unit with photovoltaic systems, and so there's the possibility of having power supply through photovoltaic systems. I think I can stop here, and of course, I'm ready to take any questions. Thank you very much.
So now, as of tradition, we have a round table. We will talk about different issues concerning the energy transition and the different areas it involves. For example, the integration between grids, between subjects, between skills. So now I would like to ask the following people to take their seat. Okay, so I'll stay here. Okay, I will start from the Marche region. We mentioned the different institutions participating in the different debates. So, Giorgio, let's talk about this virtuous circle. Let's try and understand what the region is doing, what kind of projects the region is carrying out. What are the needs and the solutions that are being adopted by institutions and utilities in general. And then we will talk about the practical applications. So thank you, Massimo, for being here. I'll give you the floor. Also, as representative of an international network, we would like to hear your opinion. Well, maybe my speech is a bit more, a bit wider than what we've been talking about so far. Well, this is what I'd like to share with you. Let's try and have a more detailed view on things. This morning, I think Mr. Capra talked about this. There was criticism concerning the lack of clear decisions when it comes to sources. In my experience, as I coordinated the definition of the regional plan related to the sustainable development strategy. This region is probably still the only one who has a detailed plan on environmental change. So we talked to the different stakeholders involved, and it's clear that we need an interdisciplinary kind of perspective involving different disciplines. The Sustainable Development Strategy considers our resilience level, so our ability to react to tragic events and emergencies, and also the need to approach climate change with an attitude of adaptation, and also the need to give value to our resources, our woods, our water sources. And it also considers the problem of poverty and how to increase equal opportunities. So in these strategies, many different topics have been touched upon. So what you mean is that you are trying, the document is trying to intervene in case of an emergency, but also it considers other things. Yes, because if you keep an open perspective, then maybe your action will be more far-reaching. We are here in Senigallia and it's raining. I think it's clear to everyone that we need lamination areas if Senigallia wants to survive. So we need areas where the most important water excesses can be discharged. We know, of course, when it rains very much, there are problems. But in the last 3 months, it didn't rain at all. So our provinces went through a drought. So if you need to create a water basin, a reservoir, why shouldn't you have a reservoir that is generally full, and in case you expect a flood, you empty it so that you can collect the water, the excess water? And if you create a reservoir, that maybe you can create some hydroelectric power plant. So I think we should think of solutions not related simply to the immediate need, but also to the possible advantages in general. The Marche region obtained the vice presidency of the working group on the adaptation to climate change within the Conference of European and Maritime Regions. And this is a very important experience. So everything we heard this morning refers mainly to the reduction and mitigation of climate change. So how to try and improve in terms of reduction of climate-altering emissions so that climate change will be reduced. At the same time, we know that we must deal with the problem of how to adapt to climate change, because climate change is already here. So in our plan for the adaptation to climate change, our analysis says that since I was born, 1960, from 1960 to 2022, we increased our temperature by 1.5 degrees in the region. I saw a graph that really shocked me. With an average of temperature between 1960 and 2010, in 1960, we were 1.2, 1.3 degrees, and then we grew linearly, and we are now 1.3, 1.2 over. So that means the climate change is here. So we need to work so that future climate change has an impact that is as limited as possible. Yes, we would like to also hear about investment plans. Well, yes, Katyusha will focus on energy specifically. Sorry, I didn't want to interrupt you, but we wanted to know about projects, financing. Well, obviously, first of all, good morning. My name is Katyusha Grassi. I'm in charge of energy planning and investment management for the region in the field of energy efficiency, renewable energy development. Obviously, what Mr. Zbriscia said is very important. Energy planning needs to be placed in the right context. When we talk about energy, we talk about decarbonization of the economy, all the economy, in all sectors, the use of resources, citizens included. So this is the strategy that the region has carried out. Also, the past energy planning was based on energy self-consumption. Now we are reconsidering things in view of the new national framework, the one that Mr. Capra already explained, the PNIEC and RED number 3. And recently, the Ministry for Innovation and for Economic Development worked in this direction. We obtained 2.3 gigawatt to be reached by 2030. It's a very ambitious objective because in the last 10 years, we only increased by 0.98. So we need to double our efforts. We are trying to plan to reach this objective through our energy plan that we hope to adopt by the end of the year. At the same time, we would like to adopt a strategy for energy efficiency, so produce energy where it is consumed, so self-consumption that guarantees the highest environmental sustainability, and then finding suitable areas that are sustainable. So we have already planned several investments, about 46 million euros, were allocated in the last few years after the pandemic to increase efficiency, energy efficiency, with specific calls for tenders for companies to develop renewable energies. And obviously, we don't refer just to the manufacturing sector. We finance also companies in the transport sector. So, and we work both in the public sector and in the private sector. In the public sector, we mainly focused on lighting, energy efficiency of the buildings. As for the private sectors, we invested in renewable energy sources and also the grid, because the previous energy plan showed that there was inefficiency in the network, in the regional network. And this had an impact on the production activities, especially the most innovative parts. Because, of course, it increased costs. So we talked to distributors, and we were able to identify some critical points. And so we supported the updating of internal cabinets, support to backup generators. This is our approach. We will continue to do it in order to improve the quality of our energy. Monitoring, of course, is an essential activity also within the companies, because if we want to achieve our objectives, we need to do a bottom-up kind of activity. We invested very much on hydrogen because nowadays, thanks to the financing we received from the National Resilience and Recovery Plan, we financed 3 projects for the production of hydrogen. We're talking about 460 tons per year, and they will be used for public transport. We realized that there's a lot of interest on the part of transport companies, local transport companies, when it comes to hydrogen. Of course, these are experimental projects. the region really believes in them, because we know that there is interest on the part of companies, interest for innovation. And I'm really happy to see Mr. Capra here. What we need is an industrial policy, because we finance certain activities, but if we don't have companies producing electrifiers here in Italy, then we are at a standstill, because the time required for the supply is really very long. So it's very important that the energy policy and the industrial policy go hand in hand. This would surely help. Very interesting. Maybe we can go back to this point later on. Now I would like to ask Marco Bianchini, as Managing Director of EDMA Multigas and also of a network of utilities. In the last few years, the country has been unable to become a system, work as a system. Small municipalities find it difficult to work together. But multi-utilities, for example, are making progress. And also, when it comes to regions and other bodies, we see that you are enablers of industrial development, not just of citizen services. This is a very complex time for you because, well, COVID, the pandemic for once, and then climate change, so floods. So you need the support of national bodies, but also the private sector, technological companies, for example, that provide you with the right tools to use. So this is a change that is necessary. It's necessary to create a multi-service network. So I'm here with a double role. I represent Multigas as Managing Director and also 𝐃𝐞𝐻. And what you're saying is true. Medium to small companies. My company belongs to a large group, even though it's a small company. As I was saying, we need to be close to associations of companies. Of course, my association carries out training activities and talks to the regional authorities to inform them about issues. I'm really concerned about this regulation that Cristiano presented to us. I'm more concerned now than I was this morning, because we were talking about this in at the coffee break, and this will have a great impact. We are in a regulated kind of market, and so there are very clear elements to be considered. So I don't really know what's going to happen. We'll have to be very careful, because this regulation has also great impact from an environmental point of view. And I'm not thinking about small cities, but cities like Milan, Bologna, Genoa. There are a lot of repairs done. I think we should look at things from a comprehensive perspective. Let's say a 360-degree view. So I think we will have to create kind of informal partnerships with smaller companies. Going back to what we as at Multigas do, well, we are carrying out an experimental project, and the project aims at understanding whether the percentage of hydrogen in the gas networks, that is 2% now, can reach 5 or 10%. This is an experimental project we carried out in Arezzo. We are measuring the situation. We increase the percentage of hydrogen, and we try to understand how the gas behaves in terms of combustion and other elements. We are trying to see whether it's possible or not, because if you have more hydrogen in your networks, it becomes more dynamic. So far, the distribution plant has been a very static one. Now, networks have to interface with all parts of the sector. Well, how did your approach change? Did you have to modify the way you were doing things, because exchanges with technologies producers are more and more frequent, so you need to create a very fruitful dialogue. So how does this impact your training? How did you have to change your way of? Well, yes, our approach changes. We create working groups nationally, which are very important. We exchange information, experiences. 15 years ago, companies lived isolated, but nowadays you need to look around you. I was the vice director of a waste disposal company in Tuscany for 2.5 years before doing this. So we have to consider biogas, and nowadays networks have to become something that includes all these different elements. Thank you, Marco. Stefano Bianchi, you work in an area which I love because my family is from Mantua, so we often travel there. And a utility of that size is really effective. You've managed to change very much. You reached strategic agreements. You created energy communities. So now, today we are talking about gas networks, sustainability, methane. And what about a multi-utility like yours? How can you join innovation on the one side and apply that innovation to other sectors? How do you work? Do you work vertically on these services? Good morning. We are a multi-utility service company in the area of Mantua. We serve 58 municipalities that are our members. So all benefits go to this area. So it's the municipalities. The multi-utility is the only thing that joins the municipalities together. Yes, they have to go along with each other. Apart from the project that we presented today, we also manage district heating and the Mantova hub will become a hydrogen valley. We will use 300 tons of hydrogen per year. Well, the territory obviously needs reclamation activities and other repair solutions. Well, yes, heating is very important. The town center, the inner center, is already been reached. Then we have the environmental activities. We have Aqua, a company managing water resources. They are doing these smart metering activities that we carried out on the gas sector with the water resources. And of course, the IT infrastructure is used by everyone. So smart grids are an integration of networks. So can they be useful for measuring data, or are there other advantages? Well, the interaction between networks is still very difficult because heating is one part of the gas distribution. But the approach that we use when doing controlling activities are similar. Smart metering started with the gas sector and now is being used in the water sector. So there are technologies that can be adapted. Right now, as a group, we produce 23 megawatts of photovoltaic energy. In terms of sustainability, in this case, we would need to identify some lines that, once identified, are used by everyone. And of course, authorization processes are very difficult. Now there is a law according to which you can have the authorization in 10 days. It took us a year in the past. So the political world is very far from where we would need them to be. So the National Resilience and Recovery Plan didn't simplify things, did it? No. Then, of course, we need strategic visions, but then we need to keep them for some time without changing things. Now, I would like to ask Giorgio Turchetti as a representative of the university world. So not just research, but also the university students that need to approach these kind of issues with some kind of enthusiasm. Yes, I would like to make a few comments on the role that gas, when moving from methane to hydrogen, will have on energy production. Energy is the key factor when it comes to competitiveness, according to Draghi's report to the Commission. The decarbonization goal for 2050 to limit climate change needs to be achieved using competitivity, environmental sustainability, etc. So the transition to other renewables, like solar power and wind power, it's possible. Strengthening the hydroelectric energy and biomasses without excluding nuclear energy. In 2023, nuclear energy imported from abroad represented 18% of the energy we consumed in Italy. Relaunch plans for the electronuclear plants will be implemented. In 2035, we won't have anything. 20-25 years is the time required for the first nuclear power plants. So it's not tomorrow, but it's not very far. Well, it's outside my temporal horizon, let's say. Accumulation systems are required to compensate the variability of the photovoltaic system and the wind energy system. Accumulation systems are batteries, and they allow to balance the energy load. In 2023, Italian consumption was 316 terawatt per hour, and the elimination of fossil fuels in order to offset the seasonal variability. What can we do? This is a very important problem. So we would need accumulation, but seasonal accumulation should be for around 40 terawatt per hour. Considering the cost of actual batteries, 200 euros per kilowatt hour, we're talking about a huge amount of money. Try and calculate things. We go beyond 6,000 billion euros. This is not sustainable. It's not doable. It's not doable from an economic point of view, from an environmental point of view, because think of the material that we will have to recycle them. So large-scale accumulation with batteries is not really feasible. In the Draghi report, the costs for batteries are 69% of total investment for renewable energy by 2030. These are the data that they brought. So what can we do if we use only renewable energies? Well, we could pump air, compressed air, or hydrogen. Obviously, this is a problem because if we produce hydrogen with electrolyzer, the efficiency is not really ideal. If we use hydrolysis and we pump hydrogen, the so-called power to gas, efficiency is improving. With fuel cells, but efficiency is reduced by 40%. So this is not really feasible. But in my opinion, there are no alternatives. What about air compression? Can we make a comparison? If we want to do accumulation with high pressure, 50 bars, we can do it. We can compare it with accumulation of hydrogen at 10 bars. We have mechanic energy of compression, but hydrogen has a power of 32 kilowatt hour. If we use a 50 bar compression, we can improve. But we're not ready for this. But in Germany, there is a prototype. They have the whole sector ready. They have an underground reservoir, 1,000 cubic meter. For seasonal needs, accumulation could be, reading from this figure, 1 cubic kilometer. If we store it at 50 bar, then if we store it at more, then there are some problems. Then we could reach 0.2 cubic kilometer. In Germany, there is a company that is already doing this. A study done in California I made the calculation. So the estimate is 100 billion euros for the accumulation system for Italy, and 6,000 billions for batteries. As for compressed air, we can think about this, but personally, I believe that unless we don't go back to nuclear energy, hydrogen accumulation, seasonal accumulation, seems to be the only way forward. So renewable energies are very good, but each one has pros and cons. They are a diluted form of energy. Then we have methane, oil, fossil fuels that are concentrated energy sources. And then we have a higher concentrated energy source that is nuclear energy. To conclude, the PNIEC has a specific aim. I think we will start doing something in 2035 with micro nuclear reactors that are almost ready. 10 megawatt. They are easy to transform. In 1 month, they can be installed. Thank you. I just would like to conclude. We need to have an energy plan from the municipal level to the regional level. Thank you. Thank you very much.
No. Allora, Cataldo, adesso ci sono un parere delle due imprese.
Okay, now I'd like to have an opinion of the two companies. We've listened to examples of very lively regions and highly skilled. So utilities are companies which are lively by definition. So this means that whole new scenarios of development are opening up for you. And you have to provide quick answers to the new challenges. Yes, that's true. I've followed with great interest everything that has been said, and I'd like to express the opinion of the last ring of the chain, of those who are actually on the field. And so producers have to take two things into account. First, raw materials that have to be easily available. The electric development gives me food for thought in this respect. And above all, producers have to be capable of producing in compliance with norms and regulations. And I already see a paradox here. We get requests of our products, and they request 100% service. As we've seen before, the law says up to 2%. So distributors, if they want to save money in the future, are already asking you 100%. So what should producers do in this respect? They're really the ones who are out there on the field, and they have to think about how to face the problem. We have no alternatives. This is actually what our customers ask us to do. That is why we started looking at the things to do in terms of specifications. This whole series of things to do for certifications. We started doing that with Bureau Veritas. And for each individual raw material making up our product, we have started analyzing how we can come out with a safe product. For those of you who are interested in this topic, there will be a meeting on the 29th of November. We're going to meet. We're going to be in the province of Modena, and we're going to address this topic in detail. Thank you very much. I'm going to ask the same question to Giorgio. So we're now closing this session. Can you please provide us with a comment on what you've heard so far, on possible opportunities for Automa? And can you illustrate a project that is particularly important for you? The sun has come out for this round table, so please come out with your sunny project. Something that is very dear, a project that is very dear for Automa. I'd like to draw inspiration from what the professor told us concerning the mixture of energy, the possibility of going back to nuclear. And I'd like to consider that sometimes realities is well beyond imagination. So I'd like to basically say that the most important thing now is to optimize gas networks. They're actually what we have to work on at the moment. If we hadn't dismantled our competencies in the nuclear field, which were very, very top competencies, top skills in the world, and actually you are sitting next to a nuclear engineer, well, I think that our nuclear engineers have taught many people in the world how one can produce nuclear energy. But right or wrong, we're here today, and I believe that the gas distribution networks will continue being alive and kicking for a long time. What's important for us is to make these networks as efficient as possible. Our projects all aim at monitoring and regulating these networks, also using artificial intelligence systems, so trying to make predictive analysis and maintenance activities on gas networks. This makes it possible for us to make a first step towards decarbonization, which is not to replace existing technologies with new technologies, because new technologies also have their own problems and experimentation times, but our main goal is to optimize what we already have. So what is dear to Automa now is the joint application of technologies that Automa has been investing for long to go towards the direction of the maximum implementation of our networks. We cannot have total optimization, but I think we can achieve very good results. This is what we are aiming at, and this is what we would like to invite all gas operators to work on. And I already have a second question for you. What about your activity that started in the Marche region and is developing internationally? Can you tell us a bit about the countries where you are working, where you are more active, the countries which are more innovation-oriented, the countries in which you can understand that there is fertile ground to do some kind of quantum leaps in terms of development? We have been working for many years in the whole of Europe and also in Latin America. Recently, we've started working in the EMEA area and in the Far East. In Latin American countries, we're doing a great job, and we are also approaching the North American market, which is appears to be a market characterized by great technologies, but in practice it is not that technologically advanced in this respect. So we are proud that we are bringing our Italian skills to markets which have long been teaching us what technologies are. Not Katusha and Massimo, what's the thing that what's the project that is particularly dear to you and which has a very important prospect in terms of development for local companies? So the project that is the most challenging one, which contains new developments, is that concerning energy communities. There is a very strong financing, significant financing in energy communities. The Marche region has a specific regulation for the setting up of these technologies, of these communities, sorry. So there's lots of interest in this, and that's also interesting because energy communities are the ones that bring together institutions, companies, and citizens. I think that this is something really powerful. And it goes, it's very important also for the social involvement of people, because citizens can truly understand what the needs are if they are to receive the services that are delivered to them every day. Thank you very much. Same question to Marco. I mean, you're dealing with gas networks, but at the same time, you also have a direct contact with those who do innovation. So we've experienced the whole period of smart meters and what they brought about in terms of data management and artificial intelligence. Can you tell us a bit about what you are doing in terms of use of artificial intelligence, especially in the field of cybersecurity? This is already here to stay. Infrastructures are bound to increasingly use AI tools to carry out cybersecurity, because we know that those who carry out the attacks already use artificial intelligence. So I think that here too you have started working. You've probably opened a competence center that analyzes the topics of data of cybersecurity to promote your networks or maintain the value you have. Yes. Well, the issue of cybersecurity is particularly important because there's a whole series of processes of remote control, and we have to make sure these systems are governed by us and not by other people. That's a fundamental topic. Like I said, and building on what my colleague said on networks, the activities that we are carrying out and the way we use artificial intelligence refer to the experimental project on hydrogen. We are also working on the balancing of power values, so using artificial intelligence that can check the monitored data and automatically adjusts gas pressure so as to reduce it and to reduce leaks and to have less gas coming out of the leaks. So these are the two main aspects we are concentrating. And then the 𝐵𝐸MI cabinets capable of accommodating biogas, so that gas does not only get into the networks but comes back to the national managing organization. So these are the main projects that we are currently working on. Then another works on augmented reality, predictive maintenance, etc. So the 𝐃EA group will probably use will probably set aside a number of money. So what is the 𝐃EA group will work on an industrial group in 2025 for total decarbonization. So we have a clear focus. You have two choices for sustainability. So basically, you lock yourself down, you do nothing. And maybe also horses are very sustainable. They're definitely very sustainable. But I believe that our lives would be severely impacted by coming back to the nice old days in which we used horses. What we can do, we can, in a way, modify what we already do within, so that it does have a sustainable impact on our lives. So There are lots of projects we are working on. So using cloud platforms with artificial intelligence. We are investing in gas networks in this way. Then remote heating networks are already managed with the digital twin. So there is a self-learning model that helps us minimize dispersions. Then we also assume that there's lots to do in the field of water. Well, actually, 70% efficiency there. And there's 30% of the water network in Italy should be optimized and improved. Water and energy. Sorry, we didn't hear the comments made from the floor because they've been spoken out of the microphone. The speaker says actually everything we do takes time. These are minor interventions, and they all together, all these minor interventions improve the situation. Even if we have to look at the 8% record of Israel, it's very difficult. Actually, the best technologies in terms of leaks are in the hands of the Israelis. But the situation, the current situation, the ongoing situation doesn't help us improve leaks. Can you please tell us what new university courses we can have with multidisciplinary topics, with the multidisciplinary approach? Actually, absolutely yes. I have to say that 20 years ago, I wanted to launch a project in line. I'd like to do something that was already done some years ago at the Polytechnic University in Turin, an MA course in physics, in the physics of complex systems, including aspects devoted to the climate, energy systems, social networks, and so on. In other words, when we talk about networks, today we talked about gas networks, then we have mobility networks. There's a whole series of networks that we can talk about, and they can be tackled with statistical methods. There's a well-established research methodology, and then of course also with the IoT systems ranging from deep learning and the related technologies. There's just one buzzword I'd like to say. Together with my colleague Antonio, we would like to carry out an action here in Europe with the objective of organizing a congress on energy, on the current energy transition, looking at current realities with the collaboration of anyone wishing to support us in this. In Senegal, there's already people who are thinking about that. So Cataldo, one final word on a project that you are currently following. And then Marcello will tell us a bit about the household announcements. Well, I'd like to talk about the collaboration with Automa for a monitoring project. So this is a skill that completes what has already been illustrated. So we gave our contribution on the overall vision illustrated before, so starting from line products up to artificial intelligence. So we gave our contribution, we made our contribution. We have a patent, and Automa has an overall view of everything. So we're quite happy about that, and we're ready to face new challenges. Marcello, what can we say to close? What you kind of impose on us in terms of legislation is then a bit difficult to understand. And this is my usual question. How can we make sure that what you tell us is turned into the reality of utilities? Actually, today I talked about the opposite. I talked about a bottom-up approach. The minister has to work on strategies, but then these strategies have to be translated into reality. I've listened to many interesting things this morning on gas networks and on the opportunity to experiment hydrogen blending opportunities and think in Arezzo this can be done, and then also listening that suppliers are already asked to be in line with components for networks that have to be hydrogen ready, 100% hydrogen ready. This is reason for hope for me. It induces me to think that the gas networks can truly become the driver, the main driver for the development of hydrogen. Unfortunately, the European Commission has considered this blending not worth financing. So we were blocked some projects in which the blending was proposed. I think this is a mistake because hydrogen, I mean, in an initial stage, you have hydrogen valleys, you have on-site productions, and we're talking about small quantities. You cannot send them everywhere. But in the future, in Europe, we will certainly witness orders of hundreds of megawatts. This is already happening in Spain, for example, in Russia. So that will generate quantities of hydrogen that can be sent, that can be shipped. They can be sent to many kilometers away. But we face an administrative problem. In order to have a 2% value, we, had months of meetings with the fire brigade people. Of course, they have to do their work when it comes to safety. But if that 2% cost us months of discussion, well, just think what it could mean to have a 5%. But still, you have to continue doing these experimentations. SNAM is already doing them. The South Corridor from North Africa will be a great opportunity. On that occasion, we will have to build hydrogen-ready networks. So there will be engineering works, seeing the participation of SNAM, 𝐆𝐈𝐀𝐍𝐶, and we can participate. We're fully entitled to participate there. Then, I'm very happy that I've listened that the market region is trying to do governance on its projects, but we have to do it at a national level. So you often come to the market region, you may have the chance to go more in details. What I say is that this is not enough. This should be done at the national level because we have hydrogen valleys of, let's say, 1 to 2 to 4 megawatts, and they're small. We have to work as a whole system. So I've proposed to my people in the ministry to have a convention between hydrogen valleys. Because we need to work as a system. We had to think and work as a system. Some projects have been withdrawn because there's a problem of power, of supply of certain materials. There are problems in terms of delivery times. However, when things become calm again, we have to work as a system. We're talking about small installations. Renewable sources of energy have to be 2 or 3 times as much. So this means that there's the opportunity of setting up a national supply chain. And this brings me back to the Net Zero Industry Act. That's important. I have a last question, but you have to be very, very fast. Is the issue of the nuclear power addressed seriously or not? Actually, we created a working group and a platform, and in short, we will have a report coming out of that. Minister Pichetto Fratin wanted to actually introduce a hint to nuclear energy that can be worked on in the report. As a nuclear engineer, I might say that ideas might not be that clear. We should go back to the old recipe. But I have a few doubts at the industrial level. Massimo Sbriscia, yeah, I would like to ask the engineer a question and pose an idea. We have the energy communities on the electric part from renewable sources of energy. Would they be thinkable? Would they be conceivable for biogas? The answer is yes, I think so. But I do not follow that aspect, but we might be informed of that. Many thanks. Let us meet back at 2 p.m. after lunch.